Hello everyone. My name is John Rodriguez. I'm an Android engineer at Duolingo, and today I'm going to be talking about a series of learnings in my time writing Gradle plugins. There's hopefully going to be a clear track forward, but I'm going to skip over a lot of the basics. I'm going to assume that either you've written one or you have at least poked around in some. And I'm going to jump around quickly talking about some patterns that you maybe should avoid or try. And then I'm going to go really deep into how Gradle does configurations. And hopefully that'll be the value out of this talk. So cool. Said all that. The basic setup of a plugin. All right, to start a plugin, you're going to slap this on and depend on the Gradle APIs because you need to access Gradle APIs in order to write a plugin and integrate into the Gradle ecosystem. Since you're probably writing this in Kotlin, you would also add that. And you'd probably set up a manifest of this sort registering your plugin. I want to call out here that I am deliberately using compile-only configurations for all my imports. The best practice here is that you shouldn't restrict your plugin to any specific versions of plugins that you're depending on, say AGP and Kotlin. That can be a double-edged sword because of breaking changes if the plugin doesn't follow semantic versioning or versions of Kotlin change, say, how metadata is output. But usually that'll surface very quickly in the community. The idea here, though, is that you should also have a good test suite if you are going to support a range of versions of the dependent plugins. So consider adding a test suite when you that does this. The dependency analysis plugin by Tony Rowland does this really well. Okay, so you're eager to write your first plugin and you're not really sure where to start because the community has a whole bunch of them already and seem to solve all your problems. So even if you don't have a novel idea, but you just want to experiment, a really good place to start experimenting with plugins is write a convention plugin for either your open source project or your work app. Chances are that there is going to be a lot of configuration. For example, a typical minimal configuration for an Android library module looks like this. Deliberately, you shouldn't see it because it's a lot. If we zoom in, it's the usual Android configuration setup. If you can now extract this, think of like the equivalent of extract method, Option Command M in the IDE for your build scripts. You can now take a lot of that boilerplate bloat that you have to do in every module of your Android app and move it into that convention plugin. So how would that even look? Well, starting with the plugin super type provided by Gradle, you might set up an early version of your convention plugin to look like so. And in these helper methods, you would contain the exact same logic that you had in N modules, but having it all in one place. And so implementing things specific to Android applications or libraries or Kotlin setup or Spotless or what have you, you could all now remove that from your build scripts. If you want to expose configuration in your convention plugin, and I'll talk about why you may want to do that, well, I'm going to talk about it now. So say you are using a convention plugin and some of your view modules have not yet converted over to Jetpack Compose. And so you want to deliberately expose that as a facility so that you're not necessarily putting Compose on the class path of modules that don't necessarily need it. I mean, there are different trains of thoughts on this. Some people are like, add Compose there to all the things, and when we adopt it, it'll already be there. But if you really care about build times, as your app gets really big, you might want to shave off some cost. And so providing that configuration is kind of helpful in that case. As your convention plugin grows, you'll continue to add methods accordingly. If you have a lot of modules in your app, you may consider decomposing your convention plugin into subplugins, each dedicated to a subset of that configuration. So instead of having one convention for all the things, you might have a convention plugin for Android applications and one for Android libraries. But that's still very general. Then you might have something very specific to your company's app where you will have a presenters plugin or a views plugin. That's fine. I would definitely warn against going too far down that rabbit hole because by doing so, if you go too far, you lose agility in migrating your architecture. Say you're using fragments today and you want to use molecule tomorrow. You really don't want that leaky abstraction to bleed into your convention plugin. So there's no global recipe. There's no general recipe for this. You'll have to know like your architecture or your app and design accordingly. But try to stir in the side of minimal versus very specific to your domain architecture. Okay, so a good example is, for example, if you had your presenters module, you would want to add the Jacoco plugin configuration for that. And then in your views plugin, you'd add paparazzi for screenshot testing. But you wouldn't add Jacoco here necessarily because snapshot, or rather test coverage of your views probably doesn't make a lot of sense. So that would be a good example of why you might want to diverge into convention subplugins. A nice way is to stay at this level, again, as I mentioned, is if your view layer later migrates to Compose, or if your presentation layer moves from RxJava to, say, Molecule, you can encapsulate that and not have to minimally update too much in your convention plugin. Okay, so like I said, we removed all that boilerplate to like one line in every module build script. You may want to take that a step further and say, why even put it in every module? Let me just put it in the root module and do sub-projects and boom, done. And that's fine. That's convenient. However, it is helpful to know that this results in cross-project configuration, which is a fancy Gradle term that means all your projects need to be configured from the root project. They cannot configure themselves independently. For now, that's okay because Gradle's configuration phase runs on a single thread. And so until there's a new alpha feature called isolated projects that will allow you to parallelize that configuration. When that happens, using things like subprojects immediately becomes an anti-pattern. So it's really about, do you want to pay it down that debt now or later? At least be warned. Another effort that's really important is in EAP right now. It's called declarative Gradle. If you want to learn more about that, go 2 hours back in time, because Iñaki and Nelson already gave a great talk on that. But I'm just going to surface it here, assuming you didn't go to that talk. It provides the ability to take a lot of that declarative, as the name puts, the settings out of either your build scripts or your convention plugin and move it into a static global state in your settings.gradle.decl. TLDR, all that means is now you have reasonable defaults, and Gradle will automatically propagate that state to all your modules instead of you having to either, in the previous case, everything in your build script repetitively, or moving it into your convention plugin, but now applying your convention plugin to end modules anyway. Like it's better, but this is even better. Like Gradle just taking care of all that for you, and you not having to think about it, and then providing reasonable defaults, overrides rather, in the specific modules that warrant them. Okay, let's move on to a completely different part of what you may encounter when dealing with plugins. How do I wire tasks? I am going to assume that you know what a project or a module is in Gradle speak. I'm going to assume that you know what tasks are in Gradle speak and their association to projects. Not going over that. The canonical example that you might have seen is this producer-consumer problem. So I have two tasks, as the names imply. The producer will write something to a output file, and then the consumer will consume something from its input file. And then the magic is, how do I have producer and consumer communicate? And so following this canonical example, you'll see something like this in the Gradle docs. You may be tempted to, if you notice that last line, add an explicit depends on to the consumer. There are various reasons where that might be good or bad, but the TLDR is avoid depends on where possible. And in one very good case of that is because of the producer flat mapping its output as input into the other task, the consuming task, Gradle will automatically know, okay, there's a task dependency here, and it'll link it for you. Whether you use Gradle's canonical version of that, or I'll allude later to how AGP does its own form of task wiring, use that as much as possible. The moment that you start depending on explicit tasks, you'll then have to figure out, all right, how do I get a handle to that task? And that's where the problems start coming up. So I'm kind of showing my cards. Depends on. When do I use it? When don't I? So here's a good example. You have this, especially in Android, I want to be very careful about using the word variant because I'm going to talk a lot about Gradle variants, and it is not the same as Android variants, but there is a mapping between both of them that make them kind of, so I'll show that later. For now, I'm talking about Android variants. The debug, the release, if you have flavors, the free, the paid, that canonical example here. So maybe you have a task that you want to be that anchor task. It's like when you run assemble and all of a sudden it runs assemble debug and assemble release, that. So if you are controlling both the anchor task and the children task, yeah, depend on it. It's in your plugin. You know the domain. When it changes, you will know. Or well-known anchor tasks. So if you've worked with Gradle or even Maven before, you know that they have the assemble task, the check task, and things you can hook into. There's also the test task, which there are kind of gotchas in that, but at the same time, everyone knows you're probably running a test. Notice that it doesn't say JUnit, or I don't know who uses testng, but I know it's an option. But the point is you anchor to test. The implementation of how it runs tests is a implementation detail. So sure, just you can anchor onto that. But here's an example of something not to do, which we did in Paparazzi for a long time because we just kind of had to. We were trying to figure out all the different compile tasks that could be present from all the different ways that you may want to configure your project. And, we thought we were smart, and I should say not we, but me, because I wrote this, I know what the variant is for the Android, the Android variant, so I'm just going to know the names of the tasks by doing this string interpolation, this variable interpolation, and hook into that. That's great, but now there's no guarantee that every time Kotlin or AGP updated to a new version that I wasn't going to break, or rather Paparazzi wasn't going to break as a downstream task. So that being said, there will be times where you'll just have to work around things and hack things. We're all engineers here. We know how it is. But again, buyer beware. Yeah, so try to avoid that. So as I mentioned before, one thing I should really kind of point out as well, that's not always obvious. So secret feature is a Gradle module, and there are 2 tasks that are associated with that project. Every task is associated with a project. There's no free floating task. So every time you're creating a task, you're really creating a task anchored to a project. And so in this case, secret feature is a module or project, they're synonymous, and there's 2 tasks, and one of them depends on the other, but it's all within that same module. That's a good reason to use depends. But then you'll have cases like this, where you want to go cross-project. This is a common way to really write bad Gradle, and it's something to be extremely mindful of, and it's also the most painful to get right. So you may have seen something like this. Please don't ever do that. Do not have feature 1 ask Gradle for the next module and peek into its tasks. If you've done it, that's fine. I forgive you, but don't do it. Okay, so then how do we do it? And so this is where the talk gets really deep. We have to understand what configurations are. And so configurations kind of serve 3 purposes, and they're all similar, but they're not. So let's just talk about them. The one that we all know is declaring your dependencies. API, implementation, compile only, that's what we know them for. They're kind of also used to resolve dependencies, and I'll talk more about that. And then they're also used for exposing artifacts and dependencies. And so the canonical example is, raise your hand if you've seen this graph. Wow, yeah, everyone's seen it, cool. And I'm not going to go into it because that would be boring, and this also is only for the Java plugin, and we're all Android developers, so this is only a small subset of actually what it looks like on Android. But needless to say, if I put these 2 things next to each other and I just color code it, that's it. So the green one, the declaring of dependencies, is what you'll actually put in that dependencies block, like so. So all these are when you use a configuration as a declaration configuration. If you wanted to make a custom configuration and wanted it to act as a declared configuration, this is how you do it. You have to toggle resolved to false and consumed to false. Well, what if instead you want to make it not declared dependencies, but resolved dependencies? Cool, flip that bit. And what if I want to expose them? Yep, just flip them around. Great, that's easy. Cool. So these are the many options. But wait, we're engineers here and we remember our truth tables. There's a fourth possible state, right? Yeah, by the way, that's a default state and it's the one you should never use. And also, you remember when I said those dependencies, that's for appearing in your dependencies block? Turns out you can put the other ones in the dependencies block too, and Gradle won't really fuss about it. So that's annoying and part of the reason maybe why configuration education has been hard to come by. I will say that in Gradle 8.4, we've now have at least a better API for this. Don't do this anymore. Instead, use the more readable APIs to ensure how you declare your configurations. Now, cool. A configuration can be in 3 different forms, but I haven't really explained how they're used. So let's go back to basics. I have 2 modules, a consumer module and a producer module. This could be your app module and a views library, whatever. And that little snippet in the dependencies block is how you link them together typically, right? Very, like, come on, John, what are you doing? We know this. So when you actually declare that as an implementation configuration, what Gradle would immediately do in the background is assign 2 more configurations. This is where the resolution and the consuming configurations come in. So you write implementation, but the producer task does not see implementation. It sees runtime elements. And consumer doesn't see implementation. It sees either compile class path or runtime class path. And why do I say either or? Well, it depends on whether you're compiling or running the app. It actually serves both purposes from a Java versus Java C or Kotlin C perspective. So to kind of drive it home, this part of the graph, I'm really focusing on this part. The green part is what we wrote. The consuming, the C, is what sees the runtime elements, and the resolving, the consuming task, but that's the other thing, is the resolving configuration goes to the consuming task, whatever. But how can we even understand this even better? So take a module, run the dependencies task, and ask it, show me only this configuration. And you'll see this. It's going to be the top level dependencies, basically what you declared in that dependencies block, and whatever a plugin might have also added. But it's still top level. Now, the thing to notice is because this is a declaration configuration and it has that N, it's not meant to be resolved, and this is the tool's way of letting you know that if you look out for it. Now, let's do the same thing, get the dependencies for the same module, but instead of asking for implementation, let's ask for the compiled class path. Remember, they're kind of cousins. But in this case, because this is the consuming tasks version of that configuration, it's going to have not top-level dependencies, it's going to have the entire resolved dependency graph, the transitive dependencies. That's what's here. And that's important to know. Well, now that we've talked about configurations, let's go a little further and talk about variants. So we've already gone over the 3 ways configurations can be used. I want you to kind of hone in on that last one of how you expose them. We talked about the consuming task. Now let's talk about the producing task. Now it turns out that consuming tasks really only consume in one way, but producing tasks can produce in many ways. And so if we look into runtime elements, remember, this is the producing tasks view of implementation. It turns out that this can deliver many, many things. What does that mean? So when you have the consumer depend on the producer, you get the Java source files, you get the Java classes, you get jar files, you get the resources, you get test dependencies, you get all this stuff along for the ride. This is how that's actually codified in Gradle. I am implementing this other module. That module is going to have runtime elements. That's an on-ramp onto the implementation highway, but there are many, many on-ramps onto this highway as well. And it really depends on what artifact, what's your output, what's the end result? Why am I linking this module to this module? We always think about a compilation with the Java or Kotlin compiler, but there's so much more than that. And so if you think of like an Android AAR, the lint jar, baseline profiles, merging your resources, all that travels over the debug or release implementation highway. And the way that it does that is through the Gradle variant. So if we look at this, let me try to speed up here. We see that every variant has its own set of attributes. This is important. This is identifying this variant for this configuration, and it defines an artifact. So if we kind of scroll down, we see now there's a secondary variant. So when you depend on another module, if you have a Kotlin module dependent on another Kotlin module, that producing Kotlin module can give you a jar, but it can also give you classes. And why is that? Well, because there's no reason to have that producing task zip up its class files into a jar, give it to the consuming task only for it to unzip it again. For those of you who've been doing Android for a while, you may remember when early AGP was really slow. This is what it was doing. It was zipping up the jar, giving it to the module that wanted it, and then unzipping it. Exploded AAR, remember that? That's what that was. That was unzipping the jar. And so AGP has become a lot better over the years, and the way it's done that is it's with the collaboration with Gradle, bypasses that and says, no, don't, when you consume for compilation, just pass over the classes directory rather than a jar. Kind of squashing that down this is what you really care about. You want to know all the variants possible, the attributes that identify, and really when I say the attributes, there were like 6 or 7 for every variant. I'm pointing out here the uniquely identifying ones. So if you're the variant class, your library elements attribute is going to be classes. If you're a resources variant, your library elements attribute is going to be resources. Okay, cool. And then also, what does it produce as an artifact? If you can kind of grok this out of the last 5-10 minutes, you just unlocked a superpower. Now, that was just talking about outgoing variants from the producer. There's another Gradle command on the consumer side called resolvable configurations. Okay, I am receiving an artifact from somewhere. What are all the, what are the attributes that define this configuration? So on the compile class path, it has its own attributes, and it also points out what configurations does it link to. Okay, so all this kind of preamble, or middle amble, was to get to this point, is now that we know that producers have variants that have a set of attributes, and consumers have a set of variants that have attributes, the natural process is when I do this is the part to really pay attention. If you have been zoning out, I apologize, because it kind of ties it all together. Consumer depends on producer, implementation, configuration. Let's say consumer is an Android module and the producer is a JVM module. I run this command. I run assemble debug because from the purpose of consumer, I'm an Android module, and so Android variants are a thing. Immediately, that implementation, keep on stumbling words, that implementation declaration configuration gets split out to the respective configuration for the consumer and the producer. And now Gradle goes to work. It says, what are the attributes that define the consuming variant? What are the attributes that define the producing variant? And now it's going to play a matchmaking exercise. It's going to say, do these things make sense? You can depend on any module, but not really. You can try, and then Gradle will tell you, nope, this doesn't make sense. And so it makes sense for Android, and I'll kind of get to it. Let's say we swap. We swap from now, instead of having the consumer be the Android module, we have the consumer be a JVM module, and we have the producer be an Android module. That's weird. Why would a jar depend on an AAR? Oh, there are reasons, not common reasons, but there are. And so now, from the consumer perspective, not running assemble debug anymore because we're not an Android module, we're a JVM module. I'm running assemble. Same exercise, different variants, if you noticed. If not, look at the slides later and do the visual diff. Same exercise here. Here's how it looks if you were really trying to compare the two. And what you'll get is that oh so glorious Gradle cryptic message. Variant blah, blah, blah declares this incompatible because a whole bunch of output. Well, hopefully now you'll have a better set of tools in the toolkit to kind of diagnose those errors. So what this says is, hey, a jar module is depending on an AAR module. That doesn't make sense. It makes sense for the other way around because Android can consume JVM modules. And so you may go, huh, interesting. How did Gradle know that? Well, it turns out if you look in the sources, the Android Gradle plugin has actually something called a compatibility rule for Kotlin where it'll say, okay, if the producer is a JVM type and the consumer is an Android type, they're compatible. Otherwise, they're not, unless you do something extra. And so this is kind of the reason why, right? The inside of a jar, the inside of an AAR, it makes sense that you would pull the classes out of a jar into the AAR. But if you do it the other way around, what exactly are you asking for from the AAR? The lint, the base bond profile? I'm like, yes, the classes.jar. We know that semantically, but how does Gradle know that? You have to inform it. And so there is a way to inform it with the introduction of things like Jetpack Compose and things like Paparazzi and things like Redwood, and anything that wants to consume the Compose runtime in non-Android ways. This problem had to be solved. And here's how you do it. I'm going to kind of breeze over it, but basically it's like, how do we make an AAR get consumed by a jar? Well, first, we have to create two artifact transforms. One that says, hey, when I get a jar, I'm going to pass that jar along. That's what the identity transform is. It's like input is the same as the output, the identity matrix. When I get a jar, I'm going to send it right back out, but I'm going to call it, instead of jar, I'm going to call it AAR as jar. That's my new type. But when I get AARs, I'm going to run it through this transform called an extract classes transform. And that's just going to pull the classes.jar out. And I'm still going to call that an AAR.jar. So now I found a way to coerce the two producing types that I need into a single consumption type. Now I have to do a little more boilerplate and say, okay, from the thing that's consuming this, I want release artifacts that speak Java. And the key part is that artifact view at the bottom. I don't want everything that can travel down this implementation superhighway. I only want the AAR as jar type. It's very key. And so there's a little bit more boilerplate. All that means is now in the bottom, you have this new configuration that you could put in your dependencies block that now, from a JVM perspective, can take AARs and knows what to do. As I alluded to before, this is how Paparazzi supported composables. There was really no way to kind of figure this out otherwise, because Paparazzi at the moment is a JUnit test rule, which means it lives in a JVM module. But the composable annotation, until Compose moved into a multi-platform project, it was solely Android. How does one get like the composable snapshot stuff out of there? Through this exact exercise. And kudos to, I think, Jeff Howe for implementing that in the repo. Kotlin, I think repo also had some similar exercises we had to do. All right, so let's see, how are we on time? I think we're all right. Let's move into now an example plugin. It's going to be a really basic plugin, but in that we're going to see a lot of interesting gotchas. So we're going to make a project printing plugin, and all it's going to do is it's going to print all the sub-project paths in a multi-module project, and I'll explain exactly what that is. But for step one, we're going to say each project produces its own path, and the root project, the one at the very top, colon, if you're familiar with Gradle, it'll consume and aggregate all those paths. And for those curious, this is the project hierarchy we're using. Right now, they're all JVM modules. So your produce task, nothing surprising, takes in the path, spits out a file. The printer, the aggregating task, it's going to get a bunch of files, and it's just going to print them all out. And so that's how the consuming task works versus the producing task. The magic is going to be in this plugin. This is stolen from the dependency analysis plugin, because it does a really good job of having canonical ways to write plugins code. What it does is it says, okay, am I the root project? If so, configure the root project. Otherwise, do the configure project. What is that even? That's some slide stuff I forgot to edit. And so was that. Magic move, thanks. So configuring the project looks something like this. This is, again, the producing task. I am the producing project. I am going to write my path into basically the property of this task, and I'm going to send my output path to this. Now this is where it starts to get a little hairy. It's like, okay, I'm the producing task. I'm going to create, I know the naming really sucks. For a producing task, you create a consumable, not a consuming, a consumable configuration. And so that's what we're doing here. We're saying, okay, I'm going to create a gateway to allow other people to consume my path. And I am going to set this attribute because I want to make sure that when Gradle is doing variant attribute matching, that I am unique and I'm not getting confused with all the other things that is traveling down this highway. And then finally, I wire that task's output as an outgoing artifact that's part of that outbound configuration. With me? Sort of, okay. Better than I thought, so okay, good. Now and this is how you do the boilerplate of creating a new attribute. From the root project perspective, similar, I'm going to declare a configuration, magic move, and then I'm going to make not a consumable configuration, but a resolvable one, because I'm on the other side, I'm the consuming project, and you may notice that it extends from declarable, and also uses the same attribute, because again, on both sides, they need to speak the same set of attributes, or at least have reasonable tiebreakers via those compatibility rules. Otherwise, Gradle will bork. Finally, you register your consuming task, and you point it to that resolvable configuration that you just created. Now, this is a cheat in this first phase, because I know that all my nodes are going to propagate their state up to the root, and that's it. I'm going to do an all projects from the root project. Yes, I just told you not to use that. I'm using it here. This is why this is the first approach. It allows me to focus on other parts of the complexity here. But the key part here is for each project, I'm going to add that individual project to me, the root project, using that declared configuration. This is the equivalent of, in the root project build script, writing a dependencies block and adding each module line by line. This is the coded version of that. Okay, so I do JVM sample print projects, and I get a bunch of output that shows the configuration phase. It says, I am the root, I'm the project, I'm configuring, and then finally I advance to the tasks, and yay. I, from the root perspective, was able to obtain all the project paths from my children and printed it out. Again, kudos to the dependency analysis Gradle plugin for providing that canonical example. Now, you may have noticed that I had to run print projects from the root project, and that's fine. What if I wanted to run print projects from another project, not the root, not colon, but app or core featured 2? Well, if I do that, it won't work because the way I've designed my plugin. And so I need to make it more robust. So design take 2, I won't just have the root project consume and aggregate all the data. I'll have any relative root in the project. This is important because this is how the Android Gradle plugin does all the merging things. Merge resources, merge lint rules, merge whatever. It has to do this because when you run app : merge resources versus core feature : merge resources, they will do the same thing, but it'll be scoped to whatever its relative transitive dependency graph is. Make sense? And so design take 1 was great, but you're limited to always having to run from root. This is great for Dropbox Focus, which is always going to work in your settings.gradle. This is great for, again, dependency analysis plugin when you want to know from the top app what the project health is. Wouldn't work for, again, the merge resource style tasks where anywhere in the graph you want to execute this and go down. So how do we fix this? It turns out it's not that much. I'm going to first refactor root project and project to something hopefully more readable, like resolvable and consumable project, because what this means is now it's not root versus everyone else. Everybody in the relationship is a producer and a consumer. It's just that the thing that it produces may be consumed elsewhere, but it may also consume from elsewhere, and that's the fun part. Now, one thing I'm also going to do is I'm not going to extend my custom declared configuration anymore. I'm now going to hook onto the implementation highway, and I'll see why. I'll show you why in a second. Similarly, I'm going to do that on the other side. Now, why did I even do that? Actually, before I get there, now, that almost worked. I mean, I made progress. All I did was change the super type of the respective configurations for the producer and the consumer. But now I got this. That's odd. So why is that? Well, if you scroll to the top, now I'm getting a bunch of like gobbledygook. And why is that? Well, because when I was using my custom configuration, I controlled who traveled on that road. Again, when you go use the implementation configuration, you're getting everything. And so I'm getting jars. Even though I just wanted project.txt, I'm getting everything. And now I'm trying to print out the Kotlin standard library, which is why it's printing out that way. A good way to kind of drive this home is there are projects that whenever you want to use them, and any plugins out there that create custom configurations, if you want to mirror the dependency graph that your app uses, one way to do it is like this, where you have to create a duplicate connectivity between nodes. And that's fine if you know for sure that it won't be one-to-one with the compilation class path highway, if you will. So test implementation or a KSP, they have deliberately different class paths. They don't touch the same things. But if you do want to do a dependency analysis crawl, this is boilerplate. You'll have to just recreate a configuration, have all your users redeclare their dependencies. So that's why we moved to this. But then now, how do we solve that other problem? This is me saying, yeah, basically, remember that compiled class path brings all the things. So we can make this better. We can go to where we registered this task, and instead of just depending on that internal configuration, we can make this huge mess called an artifact view. So what this means is, okay, I know I changed what highway I'm on. I went from custom and configuration highway to implementation highway. And yes, now I'm getting more than I wanted. Let me now prune that down and only look for things that are not only the custom attribute that I wanted, the resolved projects artifact, but also let me prune out things that are not in my project. So I don't want third-party dependencies. I want only modules that speak project.txt. And this is the way you do that. So now by doing that, I get what I want. A keen eye will notice that I ran this task from lib2. I ran this task from lib2, but I only got lib4, right? You may have expected to see lib2 itself come up there. Now, the reason why I was able to get the root task in the first implementation is because, again, I was cheating. I was the root project, and I said, oh, you come to me. But now that I'm doing it, I guess the canonical correct way to do it, modules don't depend on themselves as task dependencies. And so you don't expect lib2 to ever return lib2. It's only going to return what it depends on. And so if you want to add, if you basically want the merge, it's say like, do you want the merge subtree including yourself or not including yourself? If you want to include yourself, you have to actually, in your code, include yourself. Like Gradle's not going to take care of that for you because that would basically be a cycle in the dependency graph. What is it, a self loop? My graph theory is antiquated. So yeah, that's what I just said. A module does not appear in its own thing. So back to this, how would you still depend, how would you have one module's task depend on another module's task if you don't own both tasks? Again, the canonical example being AGP. There are new APIs in AGP that make this a lot easier in terms of adding your generated source directory, being able to modify your manifest. It's like the wired API. It's a great example, and plugin authors should aspire to do similar if their plugin is not is meant to be configurable or customized. Allow people to configure it by providing the methods that will take a task provider, their task provider, and hook it into their ecosystem, and you'll maintain that as part of your ABI. Otherwise, they'll be forced to basically, depending on your type, and then you'll break them because you didn't know people were doing that. So it really depends on, do you want to make your plugin more community friendly or not? Okay, so let's recap. I think I'm over time or just about at time. Plugins are great for consolidating boilerplate build configuration, especially in the world of Android and Kotlin. This is very important. It's also great at extracting domain logic out of your build scripts. A dumb build script is the best. Put your plugins, put your dependencies, done. I don't really care about setting lint options or build features or all that. Get that out of my individual module build script. While you're extracting stuff into custom plugins, consider generalizing it and making it open sourceable, because chances are there are other Android developers out there that are sharing the same pain as you. Isolated projects and declarative Gradle should make this even easier. I look forward to both of those projects or features being released to general. And wiring tasks in your own plugin or well-documented anchor tasks only. Anything more than that, like I said, hooking into the compile task by name, you're in a world of pain. On the flip side, plugin authors make your plugins extensible. The world will just be a better place. And then lastly, configurations and variants are dark magic, but understanding them is really like, you'll go from like green belt to black belt overnight. And a huge shout out to Iñaki for helping me, because even though I'm giving this talk, I succumbed to the same problem just a few minutes ago. Here's some nice references. Like I mentioned several times, Tony Robilik's Gradle plugin is really great. It's kick-ass. Vanatick's Gradle Maven publish plugin is also kick-ass. Remember the days where everyone copied Chris Bain's publish script? Yeah, you don't have to do that anymore because someone published a plugin that's kick-ass. Look at Redwood in the Cash App repo for a great example of a minimal convention plugin. Doesn't try to do too much, but still, like, you can reason about it, even if you don't consider yourself a Gradle savant. Of course, going directly to the source of AGP is always great. It has many years of battle-tested work, and so it might have a few more abstractions, but looking at ways to understand compilation class path and runtime class paths and how it does task wiring are great lessons to grok there. And then if you want to see how task wiring and AGP works with canonical examples, that last one there, the Gradle recipes, will serve you well. They've been keeping it up to date on every AGP release for at least 2 or 3 years now, so it's pretty clutch. With that was a lot, and thank you so much.